Well, good morning, all of you. Let's get started with today's class. Let's move on to the next slide. We are starting the new unit, which is on ratios and proportions, and we'll be seeing the similar triangles and similar figures in the coming unit. We have completed the unit 5, and the unit 5 test is today after we complete a little bit of ratios and proportions in today's class. Let's get started. Ratios and proportions in geometric figure. Okay, the ratios of angles in triangle below are in the ratios of 3 is to 7 is to 10. What is the measure of each angle? Okay, I'll do few problems and then we will see differences between ratios and proportions, and then I'll ask you to work on few problems on that. Okay, let's see this particular problem where the ratios of the angles are given and they are asking us to find the angles. Okay, and let me consider that we don't know the amount of the scale of this, but we know that they're in the ratios of 3 is to 7 is to 10. So therefore, I'll just 1 second. Okay, we know that they're in the ratios of 3 is to 7 is to 10, but I don't have the values of the angles, and we want to find the measure of each angle. Let's assume the scale to be in terms of x, and I can call, and we know the sum of angles in triangle is 180, then I can use this 3 times the scale plus 7 times the scale x, I'm calling x to be the scale, and 10 times x. Adding all the angles, we get sum is 180. We know that sum of angles in triangle is 180. Let's assume this, these are in the scale ratios. We know that they're in the ratio of 3 is to 7 is to 10, and we will assume the scale to be x. Then we will have 3x plus 7x plus 10x equals 180. Further, we can simplify and solve the value of x. 3 plus 7 is 10. Everything is in terms of x. So further I can write 3x plus 7x plus 10x equals 180. Okay, and further if I add all the terms having x values, 3 plus 7 is 10, 10 plus 10 is 20, so I'll have 20x equals 180 degrees. If I divide by 20 on both sides, I'll get the scale x, which is nothing but, dividing by 20 on both sides, I will get x equals, so 180 divided by 20 is nothing but 9. Okay, so I'll get x equals 9. So the angles are 3x, 7x, and 10x. So substitute this further. 9 times 3 is nothing but 27. 7 times 9 is nothing but 63. And 10 times 9 is 90. So these will be our angles. Okay, I hope I'm clear on this one. What did we compare? We compared the same angles. We compared only the angles. We did not compare different things. We compared the same things here in case of ratios. Okay, let's see the next slide. Okay, I want you all to use the chat and give me what are the differences between ratio and proportion. Okay, list out at least 3 to 4 differences between ratios and proportions, whatever you know about them. Okay, I'll give you like exactly a minute and then we will discuss. Proportions are nothing but two ratios. Two ratios that are compared by equating. Okay, that's what was listed, and that's right. Ratio is nothing but comparison of two things in the same unit. They have the same unit. Proportions don't have to be of the same things, but here the ratio have to be of the same thing, or they have to have the same unit. Comparison of two quantities, to be simple. Two quantities that have same unit. Okay, that's one thing. And ratio is usually an expression and proportion is an equation. So this is an expression. But whereas proportion is usually an equation. Okay, and we also know that ratio we use a colon sign to indicate. Okay, whenever we are expressing a ratio, we use colon sign. In bracket it looks something like this. You just put two dots, right? When you are comparing ratios. But whereas in case of proportion we use equal sign or double colon. So in case of proportion we use these symbols, right? We use equal sign, which we are familiar, or we use double colon of this type where we have four dots instead of two. Okay, and we have one more difference which I'm not writing, but I will just say out. The ratios usually represent quantitative relations between two categories. And the proportion is nothing but quantitative relationship of a category and the total. So, but usual keywords in case of ratio is to every, and the usual keyword in case of proportion is out of. Okay. These are the few things which I just listed out three major things. Okay. Therefore, the differences between ratios and proportion. Okay. We saw the differences between the ratios and proportions. So let's move on to the next slide. A solve for proportions. I'll be doing the first one, then I'll give you a chance to work on the second. Okay. You're going to work on the second. So for the first one, if you are familiar with cross multiplication, you can cross multiply and solve. For cross multiplying, I'll just, so 2 is being multiplied with 3x and equal sign remains as it is, and 7 is being multiplied with x minus 3. So you are cross multiplying and you'll have 2 times 3x is 6x, 7 times x is 7x, and 7 times negative 3 is negative 21. Okay. So further subtract 7x from both sides to get negative x equals negative 21. So that gives us negative x equals negative 21. Dividing by negative 1 or multiplying by negative 1, I get x equals 21 in case of the first problem. Okay. I want you to try the second one. Okay, let's work this out. I see answers from few of you. Same procedure, cross multiply. I'll multiply 19 times 15d minus 11 equals 32 times 7d plus 3. Okay, 19 times 15 gives us 285. So I'll have 285d. So 19 has to be multiplied with both the values inside the parenthesis. So 19 times 11 gives us 209. So it's negative 209 equals. Same way, 32 has to be multiplied with 7 and 3. So 32 times 7 gives us 224. And 32 times 3 is 96. 224d plus 96. Okay, what I'll do is I'll subtract 224d from both the sides and add 2.9 on both the sides of equality. So I subtracted 224d and added 2.9 on both the sides. So that gives us our new equation, which is going to be 285 minus 285 minus 224, which is nothing but 61. So I'll have 61d equals, further I have 96 plus 209, which is 305. Dividing by 61 on both sides, I get d equals 5, which majority of you had, and that's right. It gives us d equals 5. Okay, I hope this is clear. We will do once again same thing. I'll do the third one and you are supposed to solve the fourth one. Okay, try to solve the fourth one. This is your third problem and this is the fourth. I'll do third and you can solve the fourth. Same way, once again cross multiply 4 times 2 and y plus 2 times y minus 5. So that gives us 4 times 2 is 8. Here I need to multiply y with both the terms over here, and then further I need to multiply 2 also with both the terms on the other parenthesis. So I need to multiply 2 with y and 2 with negative 5. So I'll have y times y is y square, y times negative 5 is negative 5y, and 2 times y is plus 2y, 2 times negative 5 is negative 10. So further if I simplify, I will have 8 equals y square minus 5 plus 2y is nothing but plus 3y, right? Or negative 3y, sorry. Negative 3y minus 10. Okay. We are getting the quadratic equation and we can subtract 8 first from both the sides to get 0 equals y square minus 3y minus 18. Okay, this is what we have. We have a quadratic equation. We have different methods by which we can get the value of y. One of the method is by uh, a quadratic formula. The other one is we can use the factoring method. So using factoring method, I know that this is 6 times negative 3 is negative 18. I know that, so I can write negative 6y plus 3y. So I can split this in this manner. And further I can solve by taking y common here, which gives y minus 6. And if I take 3 here common, I have y minus 6. So I'll have y plus 3 times y minus 6. 0 equals y plus 3 times y minus 6. To get the values of y, we have to equate each of them. So I have y plus 3 equals 0 or y minus 6 equals 0. Subtracting 3 on both sides, I get y equals negative 3, or I can have the values by adding 6 on both sides here to get y equals 6. Okay, these are the two possible values for the y. Okay, same way you may have the quadratic equation of the fourth one. I want you all to solve the fourth one. I'll give you like a minute. We'll start the same manner. We have to do cross multiplication over here as well. So multiply 3k plus 5 times 9 minus k. Okay, multiply 3k plus 5 times 9 minus k equals 15 times of k plus 3. Okay, let's use different color so that we are not confused with. So first multiply 9 with 3 and 9 with 5. 9 times 3 is 27, so 27k, and 9 times 5 is 45. I'll have plus 45. And further I have k times negative k times 3 gives us negative 3k square, and I have negative k times 5 giving us negative 5k. Okay, that's our left side simplification. On the right side, I'll have 15 times k as 15k and 15 times 3 as 45. Okay. Put all the k terms together on the left hand side first. 27k minus 5k gives us 22k. So I'll have 22k negative 3k square plus 45. On the left side, and on the right side I'll have 15k plus 45. Subtract 15k and 45 from both the sides. Subtract 15k and 45 from both the sides. So that gives us these two terms will get crossed out, these two terms will get crossed out. So I'll have 0 on the right side. And here 45 minus 45 will get crossed out here. 22 minus 15 is nothing but 7. So I'll have 7k minus 3k square equals 0. So further I can say that I can take k common out, and I will have k minus 7 minus 3k equals 0. This can be written as either k equals 0, you can write it in two manners. K equals 0, or you can write 7 minus 3k equals 0. You can write k equals 0 or 7 minus 3k equals 0. So one of the solution is k equals 0. Here we'll solve further and get the values of k. Add 3k on both sides to get 7 equals 3k, and dividing by 3 on both sides, I'll have k equals 7 over 3. So dividing by 3 on both sides, I'll get k equals 7 over 3. This is the another solution. So we have two solutions. Okay, let me check if you had those answers. Okay, let's move on to the next slide. Okay, we saw what was ratio, we saw what was proportion. We are seeing the next terminology, scale. A scale drawing is a drawing that has the same shape as the object it represents. The scale is the ratio that describes how the dimension in the drawing are related to the dimension in the object. Okay, scale, this is the definition, is the ratio that describes how the dimension in the drawing is related to the dimension in the object. Or the 3D model can have, 3D models can also have a scale. Scale is usually written in unit ratio. Okay, for example, a map has a scale of 4 inches is to 1 mile. So whenever we have a 4 inches on the map, it represents 1 mile in reality. Okay, so here they have an example. How far apart are two cities that are 10.5 inches apart? Okay, on the map. Okay, we know that 4 inches is 1 mile. Okay, and we want to see how far are 10.5 inches is how much. Let me put this as a question mark. I'm solving in this method, but if you are comfortable with any other method, you can use that as well. Let me put this as a question mark, or let me call this value as x. I don't know how far apart they are in reality. Let me call it as x. Once you have that, you can just cross multiply once again. You can use that cross multiplying technique which I taught you and get the value of x. So you can just cross multiply here itself. So you'll have 4 times x equals 10.5 times 1. Okay, then further you can simplify by dividing by 4 and get the value of x. So 10.5 times 1 is 10.5, and 10.5 divided by 4 gives us 2.625. So 2.625 miles. Okay, as this one was in miles, x also should be in miles. This was in inches and this was in inches. Okay, now they are asking the next one. I'll do one couple of more problems for you all to get a hang of this technique. Okay, the scale that they have given is 4 inches is 1 mile. So write the scale first. Okay, now what they have given us, if two cities are 62 miles apart, how far apart are they marked on the map? Okay, they are 62 miles apart. So mile is located on the right side, so write 62 miles. And you want on the map how much? This time I don't know this particular value. Let me call this as x. And once again you can use the same technique of cross multiplication. 62 times 4. Okay, multiply the ends. 62 times 4. Similarly multiply the ends here. X and 1 equals x times 1. Anything multiplied with 1 is the same number. So x times 1 is x itself. And further you can simplify 62 times 4. It's nothing but 248 inches. So the answer is 248 inches. You have to, once you get this, you have to write in sentence. Usually, you should write in sentence. They should be marked 248 inches apart. They should be marked 248 inches apart. Same way for the above one, you should have written the two cities are 2.6.25 miles apart. Okay, I hope I'm clear on how to work on the problems related to scale. Let's see the next slide. Okay, I think this will be the last slide. After that, I'll give you time to work on your test. Find the scale for each drawing. Okay, a length on a scale drawing is 6.5 inches. That length on an actual object is 91 inches, and they have asked us to find the scale. Okay, I'll do one of them, then I'll give you time to work on the second one. Okay, scale drawing, we have 6.5 inches. In reality, the length of the object is 91 inches. Okay, and they are asking us to get the scale. I just want to know on the scale 1 inch is how much in reality. 1 inch of scale drawing is how much in reality. Okay, this I don't know, and I'm finding the value of x. So same way you can cross multiply and get the value. Okay, the first one was given to us was scale drawing. Second one that I'm doing is a scale that I'm trying to find. 6.5 inches of scale drawing is nothing but 91 inches in reality. We just want to have a scale. What is 1 inch on map should indicate how much in reality. So I don't know that particular value. So I'm finding that using cross multiply. So I'll have 6.5 times x, because these are the two ends. So I'll have 6.5 times x equals 91. Because 91 times 1 is 91 itself. And further dividing by 6.5 on both sides, I'll have 91 divided by 6.5, which gives us x equals 14. So the scale, the length of they had asked us the scale should be 1 inch on map should be equal to 14 inches in reality. Scale is 1 inch on drawing is 14 inches in reality. That's your scale. Okay, that should have been your final answer. I'll give you like a minute or so. Just complete this one. Okay, use your chat once you have the answer for this. So the scale drawing was in terms of centimeters. So we had 26 centimeter represent in reality 3.25 millimeter. Okay, this was our scale drawing. And we are trying to find the scale. So 26 centimeters, if you drew on a paper, it represented 3.25 millimeter. So we just have to find 1 centimeter of drawing is how much? Okay, this time we are trying to find 1 centimeter of drawing, because drawing is in terms of centimeters and not in terms of millimeter. And then you cross multiply to get 26x equals 3.25 times 1 is 3.25, and further divide 26 on both sides to get x equals 0.125. So I get x equals 0.125. This will have the same unit as, x will have same unit as the above one, which is millimeters. So x is in terms of millimeters. So the scale is 1 centimeter of drawing is 0.125 millimeter in reality. Okay, I hope this is clear. Okay, I want you all to use rest of the class time to work on your test, which is there on the hub. So please log into hub and complete your unit 5 test. If you have any questions, you may text me individually. Your time starts now.